Hello. Hi guys, how are you? My name is Prashant Jain, author of 10 plus books, most viewed IOQM educator. Today guys, we are going to do factorization. I'm just checking if we are live. I think we are live guys. Yes. Am I audible guys? Am I audible properly? Yes, the RMO workshop has started already. Am I audible guys? Please tell me if I am audible. If I am audible guys. Today we are going to do something very important, factorization of polynomials. It is going to be the foundation for algebraic identities, algebra. In fact, the first lecture we did was foundation of number theory. This is going to be foundation of algebra, right? This is going to be foundation for algebra. So it is my request that all of you should like this session before we start, right? And so these are certain links. First of all, you should definitely follow this channel. This is my personal channel of Unacademy. In this channel, you will get all the updates. Even if you are missing out on any lecture, you will get the update here. Okay. So IOQM PYQs and the worksheets of recorded sessions are also available. So now, as you can see, the lectures of English are going to be every Wednesday. Last week we did something related to number theory. In this week we are going to do algebra. So this is the paid course. If you are willing to go for the Zoom classes, one-to-one mentoring is there. So then you can go for this session, and the description, the link is in the description. You need to buy 1 year subscription of Olympiad Gold. Okay. Sir, IOQM cutoff for certificate. Guys, let's talk about it later because there has been lot of talking on the results. The results will come very soon. The scores will be out first. So we'll see to it. We'll see to it, right? Okay. So guys, first of all, what do I mean by factorization of polynomial, right? We all know what are polynomials, the degree of polynomial. So let's assume that this is a quadratic polynomial, right? This is a quadratic polynomial, right? Now, I can factorize it in two linear polynomials, right? So, the basis of factorization, which I want you to understand very properly, is that if Px, if we are factorizing polynomial Px into this, it implies degree of Px must be equal to degree of Qx plus degree of Rx. Okay. Please note it down guys. This is very important. Total degree of Qx and Rx should be equal to degree of Px. Okay. The live is in English. These lectures are in English. I have already told you these things. This course is going to be in English, complete English. And in the future time, SPS sir will also be taking these sessions. SPS sir will also be teaching in English, right? So, what do I mean by factorization? What do I mean by factorization? And what will this mean to me, right? So, if you see this polynomial Px, x square minus 5x plus 6. Now, when I am putting P2, you can see I am getting 5 minus 10 plus 6 is equal to 0. Now, this implies x minus 2 is factor of x square minus 5x plus 6, right? Similarly, I get P3 equal to 0, because of which x minus 3 is also factor. Now, what is the name of this theorem? Can you tell me the name of this theorem, right? X equal to 2 is called 0 of polynomial, right? 0 of polynomial. What is written? Let's consider polynomial Px. P of minus 4 is equal to 0. The value of x for which Px equal to 0 are called 0 of polynomial. Now, this is something which is assumed to be true, which I am assuming that you know it. Like I am assuming that you already know it, right? The thing which is to be done, is the factor theorem. This is called factor theorem. Yes, Arindam Chaudhary is correctly mentioning the name of the theorem. not factory theorem, like somebody is saying factory theorem. It is not factory theorem, it is factor theorem, right? It is factor theorem, right? So this is the basis of factorization. This tells us that polynomials can be factorized, but this is largely hit and trial. If you can see, this is largely hit and trial method. If you are putting some value and getting the value of polynomial to be 0, then that linear factor is the factor of that polynomial. It is a hit and trial thing, right? In this lecture, we will be doing certain methods which helps us directly factorize without hit and try. Okay? Okay? Am I making sense, guys? Am I making sense? Am I making sense, guys? Please tell me if I am making sense. Please tell me if I am making sense. Perfect. Yes, the Hindi YouTube course will cover the entire syllabus. Okay, perfect. Perfect. So, if you have noted it down, please write DN so that I can move on to the next slide. You can write DN in the chat bot so that I can see it and I can move on to the next slide, right? RMO workshop is being held on Olympiad Gold, right? Okay, perfect. So, remainder theorem. Now, we will go a bit back in remainder theorem. Let Px be any polynomial of degree greater than or equal to 1, right? So, what is it saying? What is it saying? That if, see, like if Px is, this is division algorithm, right? You must have done it in some of the lectures, right? In your previous classes or somewhere, you must have done this, right? Okay. So, if Px is equal to, let's assume that this is a polynomial of degree greater than or equal to 1. This is a quotient polynomial. This is remainder. This is remainder. It will be a constant remainder because of one condition which I am telling you. This is linear polynomial. We have the condition that if we are dividing it with a polynomial of degree k, the remainder polynomial is either 0 or degree of Rx, remainder polynomial, is always less than degree of dx. This is the case, right? So, if your divisor polynomial is linear, then your remainder will be a constant value. Okay? Constant value, right? It will be a constant value. So, let's try to figure out. Now, when you put x equal to a, you get p of a here. This becomes 0. So, the radius becomes, remainder becomes p of a. So, you can directly get the remainder by putting value of x is equal to a. So, the basic benchmark rule here is you just need to put x minus a is equal to 0. Whatever value of x you get, you just put it in the polynomial. In this whole division algorithm equation, you will get remainder to be this. And this is precisely, so this is the explanation, this is the statement, this is basically remainder theorem. How it is useful, we are going to see in the next slide. Can you please write it down? Can you please write it down? Can you please write it down? Can you please write it down, guys? Can you please write it down? Done? Perfect. Perfect. So, this is remainder theorem. This is remainder theorem. Now, do you know what is the meaning of corollary? Corollary is logical extension of a theorem. Logical extension of a theorem. So, factor theorem is a logical extension of remainder theorem, which says if PA is 0, right, the remainder is 0. PA is 0 means remainder is 0. It implies x minus a divides px. I told you in the last lecture this symbol means divide, right? I told you in the last lecture this symbol means divide. Okay. This is for IOQM. Yeah, the syllabus is very, very similar to AMC. That is true. Okay, guys. Sir, can I do Hollandite after completing till 10th syllabus? Yes, you can do it. Hollandite, elementary algebra and higher algebra, you can do both. Perfect. So this is the logical corollary, right? Factor theorem. If Px is a polynomial of degree n greater than or equal to 1 and a is any real number, then x minus a is factor of P of a, right? We are going to write one more statement here. I am going to write it as one note. Find quadratic polynomial with zeros a1 and a2. Can you please give me quadratic polynomial with zeros a1 and a2? You can write it in the chats. You can write it in chat. Can you please give me that? Sir, I will send enlarged pizza to your address if I qualify RMO Pakka. Promise, do you eat pizza? Yes, everybody eats pizza, right? It's just that I eat it only on Saturday, Sunday. I do not cheat on weekdays. I cheat only on weekends. This is why I am so, I like to believe that I am good healthy person. X square minus a1 plus a2x plus a1 a2. This is one such polynomial, right? So many of you are saying that, sir, this is the required polynomial. Now actually I did not mean to ask in the expanded form, right? Actually this polynomial will be k times. Please make sure of this k. It will be like this. So this is how you represent a polynomial with given zeros. A k should always be there, because you can see if you are putting a1, p of a1 is 0, p of a2 is 0, right? It is the quadratic polynomial. And one more thing which you need to mention is that k is not equal to 0 and k is a real number. K is a real number. This is what you need. This is what you need. Are you getting my point? Are you getting my point? Right? So this is and for that matter, polynomial with a1, a2, an as zeros is k times x minus a1, x minus a2, x minus a. See, like sometimes we are able to factorize the polynomial, sometimes we are not able to factorize the polynomial. It is just part of the game. It is just part of the game, right? But we need to understand this thing, that if possible, if the factorization of polynomial is possible, if it is of, let's say, 4 degree, then there will be 4 linear factors. If it is possible to factorize it, there will be 4 linear factors. It can be factorized into one quadratic also. But the benchmark rule is the same, which I told you in last to last slide. What did I tell you? If Px is equal to Qx into Rx, then degree of Qx plus degree of Rx is equal to degree of Px. Getting my point? Right? Yes. Got it? Let's move on to the next. Let's move on to the next thing then. Okay. Let's see. Let's solve this problem. Can you solve this problem? X equal to 2, x equal to 0 are zeros of the polynomial. This. Find the values of a and b. Use the theorem. Find value of a and b. Find value of a and b. Like I said, the level of the problems will be easy initially, but it will go to the IOQM level. Also, in the starting, the lectures are of basic level, because I am teaching from the basic. Yes, result has not come yet. Meanwhile, guys, can you please like the video? It will be good if you can like it. 4 comma minus 4. Okay, A2. So like, see, like x equal to 2, x equal to 0 or 0. So this means, first of all, you need to understand what this means. This means f of 2 equal to 0. This is one equation, and f of 0 equal to 0. So let's put what is f of 2. When I put 2 here, I'll get 16 minus 20 plus 2a plus b, which essentially means 2a plus b is equal to 4. F of 0 equal to 0, this is very simple. All these will be 0. So b becomes 0, this becomes a equal to 2. Right? You always need to understand that if fx is, let's say, ax cube plus bx square plus cx plus d, then this coefficient is f of 0. You need to understand that the constant term is equal to f of 0, right? So value of a is equal to 2, value of b is equal to 0. Okay. Do you get it? Please write it down. All the questions are to be written in a particular copy. This lecture is to be noted in a class or copy. If you are just starting IOQM preparation, if you are doing the IOQM preparation for the first time, you are attending these lectures live, then you need to write them, write these problems, write the solutions with me. Right? You do not have to wait to end. You do not have to wait for the class to end. Getting my point? Getting my point? Perfect. Let's move on, guys. Let's move on. Let's move on to the next problem. If there is another problem, yes. The remainder. This is the direct application of the theorem. Please write it down. Find the remainder when fx is equal to x cube minus 6x square plus 2x minus 4. If this is divided by gx is equal to 1 minus 2x, find the remainder. Okay. Let's see. Let's see. So what do I do? 1 minus 2x is equal to 0, which essentially gives me x is equal to half. Now I will put half here, right? I will get 1 minus 1 by 8 minus 6 by 4 plus 1 minus 4. So 8 is my LCM, 1 minus 12. This is minus 3, right? This is minus 3. So minus 24 minus 35 by 8. Am I making sense, guys? Am I making sense? Live lectures are always at 5 p.m. Live lectures are always at 5 p.m. Live lectures are always. Yes! So one fine student, Uday Bhanu, is saying, sir, use reduction. So I am going to tell you a smart way to look at it. Because see, potentially when I put fraction values, x equal to a half is a fraction, then I have this in my calculation, which is somewhat tedious. So I am going to use my brain. I am going to use my brain. A smart method. Can I write this like this? Right? Just try to see it. In fact, not like this, because see, like I need 1 minus 2x. No, 1 minus 2x. So what I am going to write, x cube minus x square by 2 plus 11, in fact minus 11x square by 2. So like, see, like this is 6x square. I have splitted this 6x square into these two. Now the reasoning behind this is very simple. If I take x square by 2 as common, I will get 2x minus 1, which is 0, by the way, right? Now, what do I have? So just I need to put half of it here, plus 11x by 4, right? minus 3x by 4 minus 4. This is the thing. Now, if I take 11x by 4 common here, I will get 2x minus 1 again. Right? You must be worried, sir, there is calculation here also, but both these values become 0 when you put x equal to half. So, you just have to put x equal to half here. So, which gives you 3 by 8 minus 4, which is again equal to minus 35 by 8. Now, this method may not seem to be giving value here. It may not be beneficial here, but it will be beneficial somewhere else. It will be beneficial somewhere else, right? It will be beneficial somewhere else. That is why I took a very simple example to explain this method. What have we done actually? If you try to understand it properly, I have tried to generate an expression which is actually already equal to 0. This was already equal to 0, right? This is what we do to find the remainder. Okay. Getting my point? Getting my point, guys? Sir, is there any similarity in JEE and IOQM syllabus? See, like the 40% of class 11th is already covered in IOQM syllabus. Whatever you study in IOQM is going to directly benefit you in JEE, and it will definitely make you master of mathematics. When you start JEE preparation, after completing your IOQM preparation, you will find JEE mathematics to be very easy. This is like the mathematics as a subject is the biggest problem for any JEE aspirant. Why are English courses once a week? Guys, we are going to double down the frequency in the coming future, but for now it is 1 week, 1 lecture per week. The reasoning is very simple. We are still gathering the students for English course. This is the first time we have launched English course, right? So the audience will come mainly after NSE exam, October-November examination, right? So till we gather the audience, we are just doing 1 lecture per week. Okay, let's move on to the next one. Now we have quadratic polynomial. Let's try to solve this one. So I am going to solve this question, right? I am going to give you the first line of it and then you will solve it. Now I am going to write division algorithm. See, you are dividing this polynomial. You will write qx into x square minus 1. And now since this is a quadratic polynomial, your remainder may come out to be linear. So that is why you have to write it as ax plus b. Okay, you have to write it as ax plus b. Getting my point? Getting my point? Getting my point? Getting my points? Now solve it, please. Can you please solve it? Nine minus x. Somebody is saying 9 minus x. Now see, like the basic thing here is always make divisor to be 0. Always make divisor, this is the benchmark rule. Always make divisor equal to 0. So like this was your divisor. Hey guys, you understand what is divisor, what is dividend, right? It has been the nightmare with majority of the students. They get confused between divisor and dividend. So divisor is something with which you divide. Dividend is something which is getting divided. Okay. So x square minus 1 equal to 0 means x equal to plus minus 1. This is very simple. This tells us that we need to put x equal to 1 first. 1 plus 3, 4. 4 plus 6, 10. 10 minus 2, 8. 1 plus 3 minus 2 plus 6. Because when you are putting x equal to 1, this whole factor will become 0. Right? So this becomes 8 is equal to a plus b and x is equal to minus 1. So if you put minus 1 here, you will get 1, 3 plus 2 plus 6 is equal to, so this is how much? 10 is equal to minus a plus b. So you have these two as your equation. Now you just add them. 18 is equal to 2b, which means b is equal to 9, and which gives a is equal to minus 1, right? So these are the values. So your polynomial is, your remainder polynomial is minus x plus 9. Getting my point, guys? Getting my point? Getting my point? Are you guys getting my point? Right? You can write it as 9 minus x, or you can write it as minus x plus 9. But again, let's think if we can do it by that other smart technique, because with that technique, it gives me an additional information. Let's try to do this. X cube plus 3x square, right? I will write it as minus x, right? Now, I had plus 3x square, I will write minus 3. Now, what is left? See, I had minus 2x, so I have minus x again. I had plus 6, but here I am getting minus 3. So, to balance it out, I have to add plus 9. So, see, now this polynomial and this polynomial are same. You can see it. Now, why I wrote minus x? Because I was getting x square minus 1 to be common. So, this is the benefit. Now, you can directly see the benefit. The benefit of this is that you are also getting the quotient. You also got the quotient with this method, isn't it? This is the best use of this method. I think you got my point. I think you got my point. Okay. Okay, guys. Perfect. So this is a method which I call reduction. Right? This is the method which I call reduction. Right? So if you are using this method, you are actually doing reduction. So this is a homework question because you just need to check it. So I am going to go ahead. Yeah, please do it now. Please do it now. Find the value of a and b. Again, this is a very simple. Do not complicate it, please. It is my humble request. Do not complicate it. Do not complicate this question. It is a very simple problem. So these are the different typology of problems which we do. Sir, these are, yes, because I wanted to start very easy. Please try and understand this thing. This is done intentionally. This is done intentionally. Okay. This is done intentionally. Yes, the site has started working, but we are yet to get the result. Right. So we just have to put, now I am going to do it fast. P of 1 means 1 minus a minus 13 plus b is equal to 0, which means b minus a is equal to 12. P of minus 3 is equal to 0, which means minus 27 minus 9a plus 39 plus b is equal to 0. So b minus 9a is equal to minus 12. Okay, you just subtract them. If you just subtract them, you will get 8a is equal to 24, which means a is equal to 3 and b is equal to 12. I think. No 12, b is equal to 15. So a is 3, b is 15. Okay, getting my point? Am I making absolute sense here? Am I making absolute sense here, guys? Am I making absolute sense? Tell me. Perfect. Let's move on to the next problem then. Right? Now this is all these are homework. Now this is something, this is the first part of it, right? This is the first part of it. This is the first part of it. And it has a second part also. It has a second part also. This is first part. Second part is x to the power 10 minus x to the power 8 plus 1. These two values are to be found. These two values are to be found. Okay. These two values are to be found. Right. And I am giving that x is greater than 0. Let's solve for both of these. Let's solve for both of them. Sir, if I give IOQM in 12th, so like there is no relation between IOQM marks and JEE advanced marks. I have seen students scoring so high in IOQM, like 77. I know a student who is scoring 77, right? And he is likely to get 100 marks in JEE main also, right? First is -1. Result, when is result coming? I don't know, guys, please. So like I thought it will come yesterday, but it did not. Okay. Now see, like you have x square minus x plus minus 1 is equal to 0. Now this is a very interesting thing. So you have x square is equal to x plus 1. Can I say this thing? This means you have x cube is equal to, I am just multiplying it by x. Right? Now I am again putting x square as x plus 1. So I have x cube as 2x plus 1. Got it? So if I see x cube minus 2x is equal to 1. So I simply have 1 here, 1 plus 1 is 2. So the first one is 2. The first one is 2. Let's talk about this one. Let's talk about this one now. This was easy, right? This was easy. This was very easy. This was very easy to think. Sir, please teach Hindi. Guys, this is a mathematics class. Come on. This is a mathematics class. This is not English class, right? I am teaching mathematics in English language, right? This is not English course. Now, some of the people are thinking that I am teaching actually English. So, English is one subject in IOQM and I am teaching that. Guys, I, F, X, T, H, E, and these are English literals, okay. But this subject is not English. This is mathematics. See, I can crack jokes in English. People were actually thinking that I will not be able to crack jokes in English. So, you do not need language to crack jokes, right? Language is just a medium. So, this is the second lecture. This is second lecture. You can see L2. Now, let's solve this. Now, I am going to see a pattern. IOQM patterns, these go hand in hand. So, you saw x square is x plus 1. Then x cube became 2x plus 1. Now, let's again multiply x to the power x again, right? And what do I get? I get this, right? 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 Do you see it, guys? Do you see it? X to the power 4 is equal to 2x plus 3. Do you see it, guys? Do you see it? What have I done? Oh, this was x, sorry. Just a second. This becomes 3x plus 2. Okay, x to the power 4. So now, x to the power 5. This is it. I get this. And after this, I get 5x plus 3. Now, if I see the pattern, what am I seeing here? What am I seeing here? Right? Just see these two. Then this, then this, then this. Coefficient here is 1. 1 plus 1 is 2. And this coefficient is coming here. See the pattern again. 2 plus 1 is coming here. And this particular coefficient is going here. Now, what is 3 plus 2? 5. It is coming here. And this coefficient is going here. Which means x to the power 6, addition of these two. And this coefficient will come here. X to the power 7, addition of these two. This coefficient will come here. What is x to the power 8? Coefficient of these two. What is x to the power 9? See, I need to find x to the power 10 minus x to the power 8. So, addition of these two. And what is finally x to the power 10? 55x plus 34. Now, let's subtract these two. X to the power 10 minus x to the power 8. 55 minus 21 is 34. 34 minus 13 is 21. Okay. Okay. So, x to the power 10 minus x to the power 8 is 34x. And I have plus 1 as well. So, essentially I got this, right, right, 34x plus 22, right. Please write DN if you have understood this. This is the power of reduction. What is the actual meaning of reduction? The actual meaning of reduction is I am representing higher powers of x in terms of linear expressions. So, I have reduced their power. And that is why it is called reduction. I have reduced their power and that is why it is called reduction. Got my point? Got my point? Please check the calculation. If the calculation is right, please check it. Right? Now, what people are trying to say, I got your point. This is smart. I agree. Sir, see, like this is this. Now, just multiply x to the power 8 here. Right? So, I got x to the power 10 minus x to the power 8 is equal to x to the power 9. X to the power 9 was directly this. And I also got this. It's okay. It's okay. If you are using your brain, I'm more than happy about it. I'm more than happy about it. Right? I'm more than happy about it. If you are using your brain, well and good. I like it. I support it. I appreciate it. Okay. So this is the pattern, but you need to understand the pattern. What was the pattern? What was the pattern here? What was the pattern here? Leave this because there is a lot of calculation here. What you need to do, add these two coefficients. This becomes the coefficient of x in the next equation. Coefficient of x here becomes the constant in next expression. Right? Add these two, put here, put this here. Add these two, put it here, put this here. Add these two, put it here, put this here. Very simple. Very simple. Yes, this is for the next year. This batch is for the next year. Getting my point? But now this is 34x plus 22. Eventually I did not get the answer. I just got 34x plus 22. But it is very simple now, right? If you see, x square minus x minus 1 is equal to 0. Right? This is x square minus x plus 1 minus 1 equal to 0. So we have a very amazing formula known as quadratic formula. If this is the equation, then x is equal to minus b plus minus under root of b square minus 4ac upon 2a. So this formula I will put, right? I will put like I will find x using this formula. So if I apply it here, x is equal to 1 plus minus under root of 5 upon 2. Now it is clearly written that x is greater than 0. So this value will be rejected and the x will only be 1 plus root 5 upon 2. 1 plus root 5 upon 2. This is like Fibonacci series. It is actually Fibonacci series. This is not like Fibonacci series. It is Fibonacci series only. Right? Got it? So now let's put this value. 34. What was x? 1 plus root 5 upon 2 plus 22. So what do I get? 17 plus 17 root 5 plus 22. 39 plus 17 root 5. Right? Now how will IOQM ask this question? IOQM will say this is a plus b root c. Find a plus b plus c. Right? This is how IOQM authorities will ask this question. Right? This is a perfect 3 marker. This is a perfect 3 marker of IOQM. This is a perfect 3 marker of IOQM. This is a perfect 3 marker of IOQM. Okay. Okay. Please make a star on this. This is a very, very important question. It is a previous year AIME problem. Nice. Nice. Perfect. This is amazing. Find all the zeros of polynomial if fx is this and two of its roots are minus root 3 by 2, root 3 by 2. This is perfect. This is perfect. Let's solve it. This is very basic. I am teaching it from the basic. Now let's apply factor theorem here. Let's apply factor theorem here. Let's apply factor theorem here. Find all the zeros of polynomial. See, like, now to start with, there are four linear factors to it, right? So if two of its zeros are this means this is one factor and this is one factor. Now let's do one thing. We are afraid of irrational numbers, right? All of us are afraid of irrational numbers. Let's do away with irrational number. Let's multiply. This is a plus b into a minus b, which gives us this. Okay. Okay. So this is, so these are 1 zeros. Now, if I put it as 0, I can clearly see 2x square minus 3 is one factor. So can I have 2x square minus 3 as one factor? Now, we will do our trick. 2x to the power 4, right, minus 3x square. See it. I want to get 2x square minus 3 to be common, right? This is my trick. Now, I had minus 2x cube. I am going to add plus x here, 3x, right? Because here I am getting, when I take minus x as common, this is perfect. Okay. See, like, this is taken care of, this is taken care of. But I have minus 7x square here and I have minus 3x square here. So I will add minus 4x square. But since I have only minus 4x square, I have to get plus 12 here, right? Till now, it is perfect, right? 2x to the power 4 minus 2x cube is sorted, plus 3x is sorted, plus 6 only, sorry, plus 6 only, okay? Because I need to, now this, see, like, this polynomial and this polynomial is same, you can check it. Now, in this step, I take x square to be common, perfect. In this step, I am taking minus 2x as common, perfect. In this step, I am taking minus 2 to be common, is it? Yes. Yes, 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 yes. Oh, this is complicated. This is complicated. This is not complicated. I am just taking x common here, minus x. Now this becomes easier. Okay. So now 2x square minus 3 is common and remaining we have x square minus x minus 2. Now simply you can see, if I put minus 1 here, x equal to minus 1, it is one factor. So this actually becomes this. Now this I have done by hit and trial. This I have done by hit and trial, right? This I have done in hit and trial, isn't it? I have done this by hit and trial, right? I have not taught you splitting the middle term. I am going to, in coming slides I am going to, but this is something which is to be done. Okay. Okay guys, am I making sense? Right? Perfect, perfect. Now this is a pressing question. Sir, how did you get it? This is a pressing question. This will be answered in this lecture only, don't worry, right? Now this is homework guys, this is homework, okay? Actually do it, let's do it. Actually let's do it, right? Actually let's do it. How do you solve it? It is to be done by division, right? Now remainder theorem will not help here. Remainder theorem will not help, factor theorem will not help, because you are not being able, you will not be able to factorize it, right? What if the other roots are irrational? We will see, we will see. First of all, if we have a quadratic factor, then we know quadratic formula. We will be able to solve it using quadratic formula. We will get the roots, right? Let's solve it guys. x square plus x minus 1 is factor of x to the power 4 plus px cube plus qx square minus 1. 2 comma 1. Okay. So people are saying 2 comma 1. Let's see. Now, see, I have this. Okay, which is equal to x square plus x minus 1 into obviously x square, right? Now, this is something very important. If this is minus 1, I will definitely have plus 1 here and I will write ax here. So, I am going to tell you another method to cater this, another method. Why I got plus 1 here? Because minus 1 into plus 1 is minus 1. So, my constant and x to the power 4 are sorted. Now, I will compare x cube coefficient. X cube coefficient is p. What do I get as x cube coefficient here? X square into x 1, x square into ax plus a. So, this is one equation. Now, let me compare x square coefficient. X square here is q. How do I get x square coefficient here? X square into 1 is x square. X square into minus 1 is minus x square. X into ax. So, I have a is equal to q. This is another equation. Very simple. Now, x. Coefficient of x is 0 here. What is coefficient of x is here? X into 1, 1. Minus a into 1, minus a. This gives a is equal to 1. Now, as a is equal to 1, q becomes 1. As a is equal to 1, p becomes 2. This is another method. This is another method to go about polynomial questions. This is another method. Right? Right? Now, see, like this is one such class in which I will ask you, boys, can I drink some water? See, like the teacher is asking for your permission. So, there are two playlists for IOQM 2025. From which should I study? This is a very important question. If you are comfortable in Hindi and want to study more lectures per week, then you should definitely go for the IOQM recorded time-stamped course. It is available in Hindi. This is a live course. I have started a live course, but this is in pure English, right? It is in pure English. The grammar will not be pure, but the intent is very pure to teach those students who are not being able to study IOQM just because of language, right? Right? Now, yes. So, here I am going to tell you rational root theorem. Rational root theorem, right? In a very simplified sense. Now, what have we understood? What have we observed? That see, like if I am multiplying these three, right, I get x cube here, something in x square, something in this, but this particular thing is a1 into a2 into a3, right? 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 So, what does this tell me? If leading coefficient is 1, if leading coefficient is 1, first of all, these type of polynomials are called monic polynomials. What do I call this polynomial? Monic polynomial. If my leading coefficient, what is leading coefficient? Coefficient of the highest power available, right? This is a monic polynomial because the coefficient is 1, right? So, if leading coefficient is 1 and polynomial has integer 0, it implies it will be factor of the constant term. Right? It will be integer factor. Now, what do I mean by this? What do I mean by this statement? Since I have 1 here, so when I have this polynomial, now I want to do some hit and trial here. So, my hit and trial will be factors of 91, plus minus 1, plus minus 7, plus minus 13, plus minus 91. These are the only possible candidates, right? So, we are not randomly doing hit and trial. There is a process to it. There is a method to it. There is some science to it, right? Because see, like there are infinite integers, but we have restricted the number of integers to only 8. Okay. Okay. Getting my point? Now, I will just put 1. This gives me 0. Perfect. Perfect. So, since I have 1 factor, I will just simply divide it by this. Right? So, x cube. Now, I have minus 1. I had plus 19x square. So, I will write plus 20x. This way, I have minus x cube, minus x square plus 20x square is plus 19x square. This is matched. And to match the coefficient, what do I have to do? Just minus 1 plus 91 here. Now, I told you I will tell you this. I told you I will tell you this, right? So, see what is the factorization of this? X plus a into x plus b, right? So, what you need to do? You need to split this 20 in such a manner that the product of the two coefficients is actually equal to this. 13 sevens are 91, right? And finally, once you factorize it, it becomes plus 13, you will get. So, I have told you 2 important points here. First, rational root theorem. Obviously, we have just done integer part of it, right? It is used, this is a broader theorem which is used to find the rational roots, not only the integer roots. But we have done the special case when the polynomial is monic. If the polynomial is monic, monic means the leading coefficient is 1, then all the rational numbers which are zeros will be integers only. You can write it down if you want. Second thing is splitting the middle term. This is called splitting the middle term, because see, like we have actually splitted this 20 into 13 and 7. So, we have actually splitted it, right? IOQM score should be released any time now, right? Perfect. Perfect. Please write DN. If you have understood it, please write DN. If you have understood it, please write DN. How to simplify this process? Because there can be many factors. See, like we do not have any method. We do not have any method to, actually we do have, but it is very lengthy, to deterministically find the roots of cubic equation. We can always find, there is a formula to find roots of quadratic. So, quadratic equation can always be factorized, but not cubic, not by quadratic, right? Perfect. Ah, nice. Now, this is where rational root theorem will come, because now we have 6 also here. Now, let us see. Now, let us see if we can factorize it. 6x to the power 4 minus 19x cube minus 23x square plus 10x plus 8. Let us see if we can factorize it. See, like sometimes hit and trial will work. Sometimes hit and trial will not work. Sir, will I qualify with 41 marks in IUQM? I think you should be able to. Fine. Cardano's method is for cubic, but I don't think you should use it. If you see the expression, it is very, very lengthy, right? It is very, very lengthy. Double cross method. There is no method called, like, I don't know any method which is double cross method, but we will certainly. So now these two things will come into the picture. So what is rational root theorem? The candidates are plus minus factors of 8 upon plus minus factors of 6 upon, right? So this means if I talk about integers, these will be my candidates. These will be my candidates, right? 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 So upon plus minus 1, plus minus 2, plus minus 3, plus minus 6. So if I talk about integers, only these will, but you can clearly see that 1 and minus 1 are not factors. In fact, so just put f of 1 is definitely not equal to 0. F of minus 1, 6 plus 19 minus 23 minus 10 plus 8. This becomes 0, right? So this means x plus 1 is one factor. X plus 1 is one factor. Okay. X plus 1 is one factor. Yes, you will be able to qualify in 15 marks from Kashmir. I told you earlier this also, right? Now let's do f of 2. What is f of 2? 16 6 are 96. 8 19s are, I don't know what is 8 19s are. Actually, this will also not work. 2. 2 will not work because it is too big. Now let's do f of minus 2. What is f of minus 2? What is f of minus 2? 96 again plus, yes, this might actually work. 19 8s are not, it will not work. 19 8s are is very big number. 152 minus 2 is minus 92. No, it is also not working. It is also not working, right? It is also not working. So let's do one thing. Let's factorize it. I have x plus 1, 6x to the power 3 minus 19 plus 1 minus 20x square. No, not like this. It will not be like this. So see, like I have 6x to the power 4 now plus 6x cube. I want minus 19x cube. So I will write minus 25x square. You can see it now, right? I have minus 23x square. Minus 25x square into 1 is minus 25x square. So plus 2x here, right? And plus 8. Does this solve everything? Yes. So now I want to factorize this. Now I have to factorize this. Yes. This is interesting. Now if I put x equal to 4 here, now see how I am going about it. X square is 6x minus 25 plus 2 into x plus 4, right? Now when I put x equal to 4 here, this becomes 16. 24 minus 25 is minus 1 plus 2 into 4 plus 4, which is again 16. So x equal to 4 is also one factor. Now this solves everything because I have plus 1 as one factor, minus 4 as one factor. Now I got minus 4 outside. So let's try to multiply it. 6x square. Now this becomes minus 24x square. I had minus 25x square. Write this and minus 2. This is perfect. This is perfect. Right? Now I will try to split this. This is very difficult. What is 6 into minus 2? This and this. This becomes minus 12. So I will split minus x into minus 4 plus 3 because minus 4 3s are minus 12. So 6x square minus 4x plus 3x minus 2. Now if you take 2 common here, you will get 2x common here, 3x minus 2 plus 1, 3x minus 2. So finally you have x plus 1, x minus 4, 2x plus 1, 3x minus 2. Kudos to those students who stayed till here, because some of them left because they were thinking that the level of this lecture is very low. This is some high level thinking. This is some high level thinking. This problem has calculation. This problem has formulation. This problem has manipulation. It has everything. Right? Right? I did not get x plus 3. I did not get x plus 3. Got it, guys. Got it. Perfect. Let's move on. This is already done. Okay, now HCF and LCM of polynomial. Now this is something which is very, very simple. Just consider it similar to numbers. Just consider it very, very similar to numbers. What is HCF and LCM of polynomial? So I'll just give you the example. Don't read these things, because otherwise you will get confused. Don't read these things, right? So what is, let's take Px as x minus 1, x minus 2 square, x minus 3. Qx as x minus 2, x minus 3 square, x minus 4. So the LCM polynomial, HCF polynomial becomes common factor. Is x minus 1 common? No. X minus 2 is common with one factor. X minus 3 is common with one factor. So this becomes the HCF. It is exactly like numbers. LCM polynomial becomes the highest powers of everything. X minus 1, x minus 2 square, x minus 3 square, x minus 4. And it also has the similar property that hx into lx is equal to product of two polynomials, right? Like you can see here. This is the last point. This is the whole explanation of this. This is the whole explanation of this slide. You do not have to write it. Just write this example, write the HCF polynomial, write the LCM polynomial, and just write this last statement. That is it. Nothing more is required. Anyway, you are going to get these notes. Right? Right? Done. Can somebody check IOQM result has come or not? Like this learner is claiming. This is also homework. All these are homework, right? This is very simple. So like if you see it, just club A here, club B here, right? So I'm not going to waste your time with these problems. right? This is clubbing and factorizing. Right? I told you, some of the learners like to by splitting the middle term. Yes, this is perfect. Now this is something new. Let's see if you can factorize the irrational things. See, like Arindam is like me. Arindam English is of the same level as me. He used came with not. Not come should have been there, but he wrote not came. Getting my point? So his intent is correct, just like me. X square plus 4 root 2x plus 6. Now see like it is very easy to see 6 as 3 into 2. But this is very difficult to split this 2 into root 2 and root 2. Now what is the addition of these two? Is it 4 root 2? So this is the ninja technique. If you have a monic polynomial here also, just write these two in addition. This is your answer. This is your answer. This is your answer. X plus root 2, not x plus root 3 into root 2 plus 1. No, this is the answer. X plus 3 root 2 into x plus root 2. Right. Perfect. Let's move on to the next one. Let's solve this. Algebraic expression is sum or difference of two cubes. Now this is interesting. Let's solve it. Let's solve it. This is very interesting. You need to take something common. So this is part of algebra. Whatever you take common, you take common. Take HCF. Where? Take 2b common. Okay, my lord, I will take 2b common. See, I am doing as instructed. So I have 8a cube minus 125b cube. Now, as this is the preliminary lecture, you can see factorization of algebraic expression as the sum of difference of two cubes. I have given you the hint. I have given you the hint. Now, this is perfect cube. This is perfect cube. So, I have 2b here. 8a cube minus this. So, 2a minus 5b. What formula I am using? Let me write it here. A cube minus b cube is equal to a minus b into a square plus ab plus b square. Got it? 4a square plus tan ab plus 25 b square. Somebody told me that the teaching in English is just like writing with left hand. Now, for me, I have already practiced. I already have a practice of writing with left hand. So, this is going to be challenging, but we will do it. Sir, is content of this series and your course which you are premiering are the content same? Which course should I follow, sir? See, like if you are comfortable only in English, then this is the only course you can follow. Perfect. Right. Now, this is mother of all identities. I like this. I call it mother of all identities. Take, right? So see, like you take MOTH here, R from this, A from this, Mothra. Have you heard this word Mothra somewhere? Have you heard this word Mothra somewhere? So, if you have seen Godzilla versus Kong, Mothra is the mother of all titans. So that is why these are related. It's just a poor joke. So now I have 2 root 2a, root 2a whole cube here, 2b whole cube here, minus c whole cube here, and then 3 into root 2a. I'm just going to write it like this and then I will leave it. Minus 3c, 3c. This is minus here. So this is a cube plus b cube plus c cube minus 3abc, right? Right? Now, there is a very straight, so like this is, see, like this is the theorem. A cube plus b cube plus c cube minus 3abc is equal to a plus b plus c into a square plus b square plus c square minus ab minus bc minus c. Now, there are certain conclusions with this. If a plus b plus c is equal to 0, it implies a cube plus b cube plus c cube is equal to 3abc. This is one. This is one of the conclusion, right? Second conclusion, a square plus b square plus c square minus ab. You need to write this is equal to half of a minus b square plus b minus c square. This formulation is very important. If you remember, sum of perfect squares. This came in IOQM 2024 as well. This was the direct question. Now, as this can be represented as sum of perfect squares, this will always be greater than 0, and that is why we have this result. This is a very important result. For IOQM, this is going to be a very, very important result. Please write it down. Please write it down. Right? Right? Yes, triangle that side one, yes. Right? So here I can see a plus b plus c is 0. So this is equal to 3 times x minus y, y minus z, z minus x. Direct conclusion. Direct conclusion. And also one more conclusion. If I have this, if the equality holds, then a equal to b equal to c. Okay. Okay. Can you please write it down, guys? Are you enjoying it? Are you enjoying it or not? You are enjoying it or not? If you are seeing this lecture as a recorded lecture, please leave a comment right now. Please leave a comment right now so that I can understand that you are actually seeing my lectures, and also put the timestamp so that I can see it. Okay. This, this we have already done. This is very trivial. This is also in homework, right? This is homework. You just have to factorize and find the LCM HCF as per our definition. This is the product property. Yeah, this is something very interesting. No, this is not interesting actually. Or is it? Factorize 8p cube. There will be a p here also, right? There will be p here also, right? So this is very simple, right? 2p whole cube plus minus 1 whole cube plus minus m whole cube, right? Minus 3 into 2p minus 1 minus. I think this explains everything. So anyway, I am just going to write down the expression because we have not factorized completely anything. So a plus b plus c, which means this. A square plus b square plus c square minus ab minus bc minus ca, right? This is going to be the expression. The reason why I am not letting you do it, because these are very simple problems, right? I have given time to you, right? Right? This is very trivial problem. Right? This we have already done. Oh, nice. How do you factorize this? How do you factorize this? How do you factorize this? Now, this is another factorization technique which you need to understand. I am going to solve it using, and then I will give you another problem as homework, right? So, this is a symmetric expression. What do I call it? Symmetric expression, right? And homogeneous as well. Homogeneous expression, right? Please see this. Please try and understand this thing. Every term is of 5 degree here. Degree 5. Every term is of degree 5. This is one. Second, if you see, after b square minus c square minus a square is coming, a square minus c square coming, a cube, b cube, c cube. So there is some symmetry or cycle to it, right? So this is also written in my book. By the way, you can see my book for this, right? So now what I am going to write it. So this is advanced application of factor theorem. This is advanced application of factor theorem. Now please see it. Please see it. Now I can say if I put a is equal to b, then I am putting a equal to b. This becomes like this. This is already like this. A is equal to b, and this becomes 0. Can you see that this is also becoming 0? Now just go back to the factor theorem. If a equal to b is making this expression 0, this means a minus b divides f a b c. And since it is a symmetric expression, by symmetry, b minus c, c minus a also divides a minus b minus c. Now consider this as a degree 5 polynomial. If this is a degree 5 polynomial, you have 1 degree here, you have 1 degree here, you have 1 degree here. So your remaining factor will be a quadratic polynomial in ABC, and it has to be symmetric also. So there are only 2 types of symmetric quadratic polynomial. One is this and one is this. Symmetry means if you exchange a and b, you will get the same expression, right? 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 A minus b, b minus c, c minus a, and then m into a square minus b. Now, m is definitely 0. M is definitely 0. Why I am saying m is definitely 0? See, if, how do you multiply? If you take a from here, b from here, and minus a from here, you will get minus a square b, and when this minus a square b gets multiplied with minus a square, you will get this, right? And there is no way to negate this term, and there is no such term here. So this term should not arise in the first place. This means m is equal to 0. This means m is equal to 0. And this leaves you with, and then n will come out to be -1. So your factorization will be, so after this you just need to match the coefficients. After this you just need to match the coefficients. You can read this particular part. This is very simple. Guys, do not consider it as very difficult. This is not difficult at all. It is just matter of practice. You may have seen it for the first time. That is why it is striking you as a very difficult concept, but it is not difficult. Okay. Got it? Got it, guys? Minus a minus b, b minus c, c minus a into a plus b, ab plus b, c plus c. Can you please write down done here? This is my high recommendation that you see this part again and again if you do not get it. Why I am saying this as a symmetric expression, homogeneous expression? Please see this. Okay, guys. Yeah, so this is about it. So this lecture is over now. In the next lecture, I am going to do advanced factorization things, right? We will be practicing what we have done. We will be factorizing numbers as well as we will be factorizing some using identities. So next lecture is going to be algebraic identities, factorization. Yeah, these two things, right? So I hope you like the lecture. If you do like it, please spread this lecture across like all the platforms. This is, I think, this is the only IOQM English course which is going on right now, and we will be completing it for the next session so that all our English viewers can see these videos and understand the beauty of mathematics through IOQM lectures. Let's crack it.